before we get to awarding the prizes, let's go through the question. So I encourage people to, I'll read the question and then it's up to you guys. You guys can shout out what you think the answer is, right or wrong or ridiculous. So question 1, recently an asteroid was discovered with its full orbit interior to which planet? What do you guys think? I realize in retrospect that there are many planets that fit this description. But it's the tightest constraint that I was looking for. You guys have any ideas? The answer is in fact Venus. So this is a map, an artist's illustration of where the asteroid belt lies, interior to Jupiter's orbit. So that's where most asteroids are. There's like predicted to be on the order of 1 million asteroids. I think we've observed something on the order of 700,000 of them. But this particular asteroid that was discovered last year by the ZTF group, and Bryce Boland specifically, discovered one that's interior to Venus. So there are very, very few objects that have their orbits that close in, but on the other hand, it's very difficult for us to observe those objects because they're closer to the sun than we are, so the only way you can see them is when they're up in the sky when the sun is, and as you can imagine, it's hard to see astronomical objects when the sun is in the sky, lighting up the sky.
Does that potentially collide with Vulcan?
This does not collide with the predicted but not present.
You say.
I say not present planet Vulcan that was predicted to exist in the middle of the 19th century, and interior to Mercury's orbit, but was later shown not to exist because anything that's that close to the sun would be extremely bright, and we'd be likely to see it. But
How you say the name?
what's that? Oh, and the name, yes. So the name here, Ilo Chafnim, means Venus girl in the Native American language of the people who originally populated the area around Palomar Observatory in Southern California, the Luiseno Native American tribe. And so in respect to those people, given that this was made by discovery at Palomar, the name was attributed to their language way of saying Venus girl, which I think is pretty cool. Yeah, so it was done with one of the Palomar telescopes just to the southeast of here. And you can see the multiple images taken over a 3-minute or so period. You can see its position changing on the field of view. Okay, question 2. What is the closest planetary nebula to the Earth? This was indeed revealed in Ben's presentation, the Helix Nebula. A few hundred light years away, this beautiful image. And if you look closely, so the telescope that we had set up tonight, but you can't really use because it's kind of cloudy, I took this same image. You can make out a very light silhouette of the Helix Nebula. That was a 1-minute long exposure with the EV Scope 2. You can make it out, but it's not quite as spectacular as what you can download with Wikipedia. It's in the Aquarius constellation, and it should be rising, I think, later in the spring, summer, you'd be able to see it in the sky. Okay, question 3. When a star gets too close to a black hole and gets ripped apart, what is it called? So we accepted 2 answers. What I was looking for was tidal disruption event. We gave half a point for spaghettification. Don't worry, it didn't change the results. It didn't change the results. So this is a nice video showing a tidal disruption event. It's obviously an artist's illustration. You're looking at a black hole. You're sitting basically in the plane of an accretion disk that looks something like interstellar, because the science that was done in Interstellar is reasonably accurate as to what you would see around a black hole. And you have a star that's getting too close to that black hole. And as it gets closer and closer, it starts to stretch apart because of the extreme tidal forces. And when it gets too close, it rips apart. And it basically shreds this star, and the interior gets spread out over a large expanse of space and falls into this accretion disk. So what's notable about this is that in the last month or so, there was a paper put out by a group at UCLA showing a cloud of gas, not a star, but a cloud of gas that was approaching our own Sagittarius A star, our own supermassive black hole at the center of the galaxy. And each image here, going left to right, top to bottom, is a different year's observation of this cloud. And you can see the black hole should be in the upper left corner of this. And you can see that this cloud called X7 is getting stretched out as you go to later and later times. You see it's in the lower right, it's very elongated, kind of going from northwest to southeast, whereas in the top left, it's kind of circular. So this is that same kind of effect, that the tidal forces, the gravitational force is stretching this thing out. It's spaghettifying this gas cloud, and we're seeing this in real time. Okay, question 4. What star hosts the nearest known exoplanet to our solar system?
Proxima Centauri.
The answer is indeed Proxima Centauri. You can see this nice illustration showing kind of the sun at the center and where the nearest stars are to us. So Barnard's star on the upper left isn't the closest star system, but it has been observed to have planets around it. But the closest one is indeed Proxima Centauri. Proxima Centauri is part of the Alpha Centauri system, which this is the Alpha Centauri system. In the left, you see this bright star, that's Alpha Centauri. On the right, that's Beta Centauri. And then the red circle below, the faint red circle below Alpha Centauri is Proxima Centauri, which is very, very faint. It's too faint to make out with your naked eye in the sky. Alpha Centauri is very bright. You could see it easily with your eyes. It's one of the brightest stars in the sky. But yeah, not from the northern hemisphere. But Proxima Centauri is like 11th magnitude. You wouldn't be able to see this with your naked eye. It wasn't discovered until the early part of the 20th century. And it's been shown that there are 2 planets, Proxima Centauri B and D, that are both very close into the planet. That green circle represents the habitable zone around this, where water is in liquid because of the balance between the radiation from the star. And then there's a disputed claim about Proxima Centauri C that's way far out, but that it isn't clear whether or not there's a planet there or not. Okay, question 5. What galaxy supercluster does our Milky Way belong to? I accepted either Laniakea or Virgo supercluster for this one. So this is not a picture of that cluster. This is a picture of Andromeda. People probably have seen this through a telescope or as the default background on their Macintosh computer. But this is visible in the night sky. And you can see this sometimes in dark enough skies. You can see this with naked eye. I'm running out of batteries with this microphone. And together, the Milky Way and the Andromeda Galaxy make up the local group of galaxies. We're kind of the biggest players, and then there's lots of smaller dwarf galaxies that orbit around all of us, including the Triangulum Galaxy. It's not a dwarf, but it's kind of a moderate-sized galaxy. And then our local group, it's like our neighborhood of galaxies, is part of the larger Virgo supercluster and the Laniakea supercluster. And this is kind of, the local group is in blue in the center here, and here are those larger structures that Dee was talking about a bit in her presentation. And this is a really beautiful map taken by Chris Mijos and the Case Western group of the Virgo cluster, the core of the Virgo supercluster. All the black circles are locations where there are bright stars in the foreground, and so they've just covered those up because those stars are part of our galaxy and not part of the Virgo supercluster. Can you guys pick out the BCG here? The bright cluster galaxy? Which one is it, Dee? Bottom left? Bottom left? Yeah, I don't know. I think so. I believe you. All right, question 6. Does time pass slower, faster, or the same rate on the surface of the moon as it does on the Earth? More slowly or more quickly? More slowly or the same? The answer is faster. It's slightly faster, about 56 microseconds faster per 24 hours. And the reason for that is, think about relativity, think about space-time being warped by the masses around us. In the regions where you have a more massive object like the Earth is substantially more massive than the moon is, you're closer to it, and so space-time gets warped and you get time dilation. Just kind of like in the movies Interstellar, when they got close to the black hole. I mean, that was an extreme case because, yeah, spoilers. Just spoilers. time, Matthew McConaughey and Anne Hathaway's characters, it was only like an hour for them, but then their friend who was on the ship away from it, it was 7 years or whatever. So this is obviously very different time scales, but it's the same sort of principle. And so this has come up because as more and more missions are going to the moon, and not just by NASA, but by other space agencies and even private agencies, we have to come up with a way of like coordinating what we consider the time. Right now, when people talk about time on the moon, they're like NASA's just doing it in like Johnson Space Station or Johnson, what is it? Space Center, forgive me. Johnson Space Center's time zone as being the time that we refer to when referring to things on the surface of the moon. But different places are going to have, they're talking about like inventing a time zone for the moon in addition to all the time zones we have here, and potentially building some atomic clocks there that monitor the time and how it changes differently than it does here, and then setting up basically a GPS, although it wouldn't be geographic positioning system, it'd be like selenographic positioning system, orbiting around the moon to give you precise location information of where you are relative to other things. So this is all being discussed because both the European Space Agency and NASA are planning to launch things in the next less than a decade to essentially provide these things, and we want to have some sort of coordination in terms of what we refer to in terms of time and location on the surface of the moon. Okay, question 7. What element gives this nebula, and I guess I didn't say, but bonus points if you shout out what nebula this is. What element gives this nebula a red color? The element of surprise. That is not correct, Kayla. That was good, though. That was good. Spanish Inquisition. I got it. Hydrogen is indeed the answer. This is the Lagoon Nebula. This was an image taken with that EV Scope 2 out there. Here's a more substantial image taken from Wikipedia. What's that?
In his presentation, you had a thing where it said that the red color was nitrogen.
So in Ben's presentation, he had you had a slide that was talking about different colors that were represented. Yeah, I mean, different colors can be represented by different ionization states of different atoms. But I know for a fact that the red that's in the Lagoon Nebula and in many of the red objects that we see in the sky comes from what's known as the H-alpha transition, the Balmer-alpha transition from hydrogen. And one way, I'll just quickly kind of go into this. So hydrogen, our very simplest of atoms, composed of just a proton in its nucleus and an electron orbiting around that. And that electron can have various different excited states that it can bounce up to more energetic states. If it runs into another hydrogen atom, they can bump up the electron energy state. Or if it absorbs a photon, a light ray traveling across interstellar space. But when that electron gets to a higher state, it'll at some point just spontaneously decay to a lower energy state and emit a photon. And here you can see various different transitions that occur from higher energy states to low energy states and the colors associated with them. So for all of these, when it goes down to the ground state, it emits a photon that's in the ultraviolet part of the spectrum. We wouldn't be able to see that with our eyes. Whereas for the ones over here that only drop down to the first energy state, H-alpha or H-beta or H-gamma. They can be blue, green, violet, red. But yeah, I realize I'm getting the weeds here. But the red one, H-alpha, is one of the most prominent energy transitions that occurs in the universe. And so a lot of the objects that we see in the night sky that glow kind of a red color are caused by hydrogen undergoing this transition. Okay, question 8. Who was the first person to use a telescope to look at the sky? It was not me. I'm not that old. It was this gentleman, Galileo Galilei. A nice bust of him. This is a mock-up of one of his original telescopes. So he did not invent the telescope. The inventor of the telescope was this Dutch guy named Hans Lippershey. But shortly after the invention, Galileo got a hold of it and started looking and using it to look at objects in the night sky. The basic premise of how it works is light comes from some sort of distant object, goes through a convex lens, and then goes through another concave lens, and that effectively can collect more light than his eye or our eyes can alone, and also can magnify things. You can actually get a kit of this for like $50 online called the Galileo scope, and you can build it and basically see how the optics work, which is pretty cool. You can go to Florence. There's a museum called the Galileo Museum in Florence, and you can see the original telescopes that Galileo built, which is pretty cool. But what's not so cool is they also have 3 of his fingers and 1 of his teeth in this same museum that you can see, which is like pretty creepy, to be honest. They're relics, yeah, they're basically just relics. So, question 9, NASA is planning to send a helicopter to which planetary moon in 2027? It is not Phobos, it is Titan. Titan, the moon around Saturn, the second largest moon in the solar system. As a comparison of moon sizes, you can see Titan right there in the middle, only outclassed by Ganymede. But, you know, a substantial size, even relative to the size of the Earth. Previously, we sent a mission there, the Cassini mission and the Huygens probe, that landed on the surface and gave us our first shots of the surface of Titan. And it has, you know, it has subsurface liquid water. It has a methane cycle instead of like a water cycle on the surface. So there are methane clouds and methane streams and so on and so forth on the surface. And so we really want to know what's going on there, and maybe it's potential to have life. Not like the life that we're familiar with, but there might be other forms of life there. So they're going to send this quadcopter called Dragonfly there in 2027. It'll take 7 years to get there, but in 2034, potentially we'll have new images and new samples of the kind of state of the surface and the atmosphere on Titan. Finally, question 10, the Hubble Space Telescope is increasingly suffering from what blocking its view of the sky? Satellites. Other satellites is correct. So yeah, this is an image taken with HST, and you can see these streaks from other satellites that got in its path when it was taking these pictures. We knew that this was a problem for ground-based telescopes looking up in the night sky. Increasingly, there are more and more satellites that are being launched, whether it's Starlink or what have you. But it's become much more affordable to put things into satellite orbit, and so now there's like 7,000 things in orbit that are officially in orbit, satellites that are officially in orbit, and they're not just causing problems for ground-based telescopes looking up, but also even space-based telescopes like Hubble.
Jumps, like dead satellites.
What about dead satellites?
Jumps, like jumps around orbit, like parts of rockets and stuff.
Oh, debris and such? Yeah, that'll play a role too. That probably won't be as long-lived. Debris will potentially could remain there, but oftentimes will decay in its orbit and burn up in the atmosphere. But satellites usually, oftentimes when people put up satellites, they don't give them like an exit strategy, and they'll just remain up there after they're dead and not useful anymore. And so yeah, this is from one of the Starlink satellites actually, because they're closer by, and so it just like totally wipes out the image. So yeah, we know of tons of satellites up there, and we're increasingly putting more and more up there, so it's becoming a bigger and bigger problem. Here is the number of satellites versus time from 1957 to 2022. And you can see we're already up to 7,000, and it's just going to grow over the next few years. Why don't you build satellites on the moon? Well, the moon is a satellite, that's true. I mean, I'm sure when we have the capability to do so, that will probably be a planned thing. I mean, we talked about it before on putting the GPS satellites up there, but oftentimes people putting satellites in space are to serve as something relative and relevant to the Earth as opposed to the moon. And so
Part of the Artemis program is to put a gateway that's orbiting the moon.
Yes, part of the Artemis program is to have some sort of structure and around the moon so that we can access and launch from that location as a potentially easier place to be, but yeah, it's that's okay. it's a challenging problem, and there's not an easy solution other than the people who are putting up satellites to be aware and try and mitigate the problems associated with their satellites by like making them not as shiny so that they don't block out images and brighten the images that astronomical telescopes are using. Okay. Yes, so one solution is sending all of your telescopes to way, way, way out, like the Lagrangian point 2, like James Webb Space Telescope is, so that they're so far away that they're not going to be blocked by near-Earth satellites. But, I mean, maybe that's what we'll have to do for all things. It also causes problems because then you can't get to those locations to service them in the same way that Hubble Space Telescope was serviced, but perhaps that's the solution. Okay. All right, so thank you guys for all sticking around this late, and thanks for coming when it was, not the best conditions out that we could set up the telescopes. Do you have a question, Kaylin?
Do you have a favorite coin?
No, I don't have a favorite coin. Sorry.